everybody. Thank you for coming to my talk. I know there's a lot of places you could be right now, and I appreciate you taking the time to be with me instead. Today, we're going to talk about the reactive revolution in terms of RSocket and Spring. My name is Josh Long. I'm your presenter. I'm your grateful presenter. Thanks for hanging out. I know there's, like I said, I know there's a lot of places you could have been. I have a podcast. I have a couple books called Reactive Spring, Cloud Native Java that you might be interested in. I have a screencast series there at bit.ly/spring-tips-playlist. And I'm on the Spring team and have been officially for a decade. Okay, so I'm very happy to be here. What we're going to talk about today is how to build reactive applications in terms of RSocket. Now, if you've ever seen me talk about reactive applications before, you know I've usually done demos that demonstrate how to use the reactive web stack and how to use the reactive data access tiers and all that kind of stuff. And more recently, for the last couple of years, I've also been showing RSocket. But that said, since we have a little bit of time today, I figured I'd deep dive on just RSocket. So what I'm going to do is I'm going to build a reactive web application here at the Spring Initializer, starts.spring.io, and I'm going to use Spring Boot 2.3.x. I don't need to. I can use Spring Boot 2.2 or maybe even 2.1 to get access to RSocket. I think it's 2.2. And either way, 2.3 is a nice, stable place. It's got a lot of features that make it even more relevant in the cloud. It's got availability probes for Kubernetes. It's got the ability to automatically turn your Spring Boot application into a container, Docker image using the Cloud Native Computing Foundation's build packs specification. It's got support for carving up your Spring Boot application into different constituent Docker image layers. It's got support for building Graal native image images, right? Graal VM native images using Substrate VM and the Graal native image builder. It's got a lot of stuff, right? Well, that last bit is actually a separate project that depends upon Spring Boot 2.3, but either way, a lot of reasons to use 2.3. I'm not going to linger on that. All I'm going to do is I'm going to build a reactive application using RSocket, Lombok, and Spring Security. That's our service, and we're also going to build a client. So I'll go ahead and generate that as well. And let's see what we have here. RMRF downloads. Okay. Yes. So now downloads. Hit generate. Service. Generate. And we're going to open up the service in our IDE. And again, it doesn't all that much matter what IDE you use, so long as it supports the version of Java and or Gradle and or Maven that you're using. I'm using Java 8, but I should be using Java 14. If I'm honest, I'll change that to Sweet as soon as this thing loads up. Yeah, but either way, it would have worked, right? Java 8 works just fine. Nothing about this is intrinsically tied to Java 8. And in fact, while it can work in Java 8, you might enjoy using anything later than Java 9, right? Because there's a built-in support for the reactive stream specification. So the reactive stream specification underpins everything that we're going to do today, right? It underpins all the stuff that we're going to do to build applications that are support non-blocking asynchronous I/O, right? So what we're going to do is we're going to use the reactive stream specification. There's a core type here called a publisher. A publisher is a type that produces data. It publishes the data out of band asynchronously to a subscriber. The subscriber consumes that data in the onNext method. When there are errors, if there are errors, and that is very commonly a thing that will happen in distributed systems, then those are propagated through the onError callback method. And when you're done processing data, it's signaled through the onComplete method. Now, when the subscriber first subscribes to a publisher, it is given a subscription. That subscription represents the thing that the subscriber can use to request more records from the publisher or to cancel the flow of data from the publisher. This is very important because now the consumer is in control of the rate at which it consumes the data. You can't overwhelm a consumer that's driving its own consumption rate, right? This is very important because now the consumer is more stable. You can't overwhelm it or denial of service of it because it's driving the rate, right? Flow control, very simple idea. We've had to do flow control ever since there was one computer on the same network as another in the history of computers. We've just now, have that surfaced as part of the API here. Sometimes, when we talk about flow control, we hear the term back pressure. And that just means that we're pushing back against the producer of the data. We're saying, I don't want any more data, please. I'll handle what I've got and I'll ask you for more when I need it and no sooner. These terms can be used interchangeably, flow control, back pressure, etc. but it's very important that you understand the concept, if not the particular wording or the name for it. Back pressure is super useful in building distributed systems. It ensures that your services are more stable. And when we build HTTP applications, we don't get full back pressure because at the protocol level, there's nothing in the protocol that can be used to say, hey, I want to request 10 more records, and then I'll just sit here and do nothing for an hour. And then if I'm ready, I'll request some more, right? I can't resume. I can't just pick up from where I left off. I have to either take the data that I'm given or cancel. And if I cancel, I have to set up another network connection, right? There's no state involved. There's no ability to backtrack and say, never mind, I'll go back to this place I was and just request some more. So HTTP doesn't understand reactivity on the wire. From the perspective of a HTTP client and a reactive HTTP service, the best that we can do is when you make an HTTP request to a reactive HTTP service built on Spring Web Flux or whatever, all we can do is detect that the client has disconnected and then cancel the stream that's being used to create the response that's being sent to the client. We can also then transitively apply that back pressure or propagate that back pressure to all the other streams that were involved in producing the response, right? But that's a one-time trick. You can't resume. You have to start again, right? There's a brand new connection that has to be made. So I like RSocket because RSocket is natively reactive on the wire. It actually understands back pressure. It's also a stateful connection. So when one side connects to another, they keep the sockets open for the life of the applications. And multiple transactions can be conducted over the same socket, over the same connection. We say that an RSocket connection is multiplexed, right? Kind of like HTTP2. RSocket connections are also very flexible. Rather than supporting only request response, as is the case for HTTP2, RSocket connections can support many different message exchange patterns. I can do fire and forget. I can do single value in, single value out. I can do a stream of values in and a stream of values out. That's called a channel request. I can do a single value in and a stream of values out. I mean, I can do all sorts of things as a result of a RSocket connection. And either side can do this as well. Once they're connected, RSocket services are not client and service. Really, they're just requester responder, and either side can be either thing at any time, right? The requester can ask for data of the responder at any point in the future. And vice versa. There's no reason that this should be limited to the initial connection. It can just happen an hour from now after they've connected, but maybe nothing has been done. So lots of stuff that RSocket gives us out of the box. It's stateful, it's multiplexed, it supports lots of different message exchange patterns. It's also payload agnostic, it's binary, right? So it doesn't care if you use Google Protocol Buffs as you might have to for gRPC, or if you use text and HTTP basic as you do for HTTP 1.x. Etc. So it's a very, very flexible protocol. It's also super fast, and it is operationalized, easily operationalized. It's friendly for operations. And what I mean by that is it has, first of all, headers. I can't believe I have to say this, but headers are useful. WebSockets don't have headers, for example. Headers are a way of conveying out-of-band information, things like a token, which you need to do things like security. So stands to reason then that it'd be very nice to have that in my protocol. It also supports metadata that the requester of the service can use to ask the service how healthy it is, how available it is, etc. You perhaps, if you're a part of the Spring Boot community, have used the Spring Boot Actuator. Actuator are a set of HTTP endpoints that surface information about the application itself. These things are extra. They're things that we as a community have agreed to use. And if we're smart, we can write smart load balancing clients that look at that information and load balance to another node based on the information that they get from that service, from that actuator endpoint. That's a convention that we've embraced in the Spring Boot community, but it's by no means part of HTTP, right? When we implement that, we actually have a separate thread pool on the server that actually handles the actuator requests, so that even if the main thread pool is overwhelmed, we can still get a response back in time, right? So this is very convenient. It's an operational feature, but that's actually built into RSocket, right? It's not part of we don't need to provide anything extra. There's actually a metadata frame for that kind of information. So lots of good stuff here. Let's go ahead and build a simple service. We're going to do this two ways. We're going to build one first based on the low-level Reactor API. So when the engineers that built RSocket built a Java client and a JavaScript client and a C++ client, they had to pick the toolkits of choice for those respective platforms to implement these clients, it stands, of course, to reason that they chose Reactor, the thing that we use in Spring to build Spring, for their client. So we're going to use an RSocket. We're going to build an RSocket service. So we're going to actually do this low level. I'm going to build an application listener. This is just a Spring Bean that's going to get notified when the application context is ready, right? But otherwise, this is nothing. There's nothing springy about what I'm doing so far. It's just I'm using this as an event to hoist my application into existence. Okay. So RSocket factory. I'm going to receive data. And when I receive data, I'm going to delegate handling any socket connections to the socket acceptor that I'll make my class implement. Okay, that's this. We'll come back to that in a second. And then we're going to transport the data. So TCP server transport dot create, and the port that I'm going to use is going to be 8888, just arbitrary. It could be whatever you want. I'm going to start the application, and I'm going to subscribe, because remember, this is a reactive stream, and reactive streams are otherwise inert unless you subscribe. Now, here's where the actual magic happens, is in this accept method. This is where we actually do the work of providing a thing that'll respond to requests. So when the connection is made, this method gets called, and we have a setup payload. This is the payload of information that we can get if it's optional, right? That we can get when the connection is first made. That might include, for example, security, right? Credentials. Maybe you want to authenticate once for the entire connection as opposed to per user, but you can do that. The other thing that we get is a client RSocket, right? This is the RSocket of the thing that's making a connection to us. You can stash this. You can keep it in a map, and then you'll have a way of saying, oh, here's all the here's all the services that have connected to my node, for example, right? That's a natural thing to do. So what we're going to do, and by the way, the other thing is that client RSocket, it's a thing that you can use to ask the other side for information. And it too could implement socket acceptor and provide that information. In that way, it's actually a service in of itself. That's what I mean by it supports full bidirectional duplexed, multiplex communication, right? So I'm going to create an RSocket object, RSocket, new abstract RSocket. And this supports a number of callbacks that I can use depending on the kind of requests I want to satisfy or handle. So I could do availability, that gives me information about the application itself, and I could do metadata, that's extra information that I can use to communicate, the health, the uptime, that kind of stuff. I could do a channel, that's a stream of data in, stream of data out, right? That's not needed right now. I could do a single value in, a payload in, and a stream of values out. That's request stream, not for now. I could do fire and forget, right? I could say a single value in and then nothing out, a mono avoid out. But instead, for now, just to keep it simple, I'm going to send a single value in, and I'll return a single value out. Okay, request response, more or less the analog for HTTP. Now, I'm going to assume that the payload is a name, and I'm going to greet this name. So this is a name here, name, okay, and I'm going to turn it into a response. So I'll say reply equals default payload dot create name. Okay, I'm going to say return mono.just reply. Okay, there you go. That's my service. Now keep in mind, this method is going to get called for any request response interaction. So we're missing something here, very obvious. We're missing routing, right? This is the only handler that we have in the entire application for any kind of request response interaction with this service. If we want to respond, we have to do that work here. So you end up at this low level, you end up having to write a routing table and a switch statement saying, oh, if this header in the request in the metadata looks like this, payload.get metadata, right, UTF-8 or byte buffer. Once you turn that into something you can unpack, it could be a map, it could be JSON, it could be whatever, you could then look for headers, right? That's up to you at this low level, right? So for now, I've just got a very simple service, and all it does is it returns a single greeting, right? So I'm going to reply, actually, hello name, okay? So there's this. That's my response. And of course, in order to work that, I'll say mono.just RSocket. Okay. Okay, so there's my entire protocol. Request comes in, I say hello to whoever made the request. That's my RSocket service. Let's go ahead and run this. And then we're going to go start up the client and build a corresponding client to that. So client.zip. Client application. And here, basically the same thing, just in reverse. So I can even move this over here, move that over there. Oh, by the way, look at that. I forgot to block the thread, right? Because it's a daemon thread. So I need to thread.sleep, or no, better yet, system.in.read, right? So, and that of course throws an exception. I could do throws exception, or my favorite, I could do sneaky throws. Okay. All right. So now I can restart this, and I'm going to do the same thing as I did before. I'm just going to do an event listener here, and here I'm going to do a. It's also going to be I don't need to be a socket acceptor actually. I'm not sending anything back, but it's a TCP client transport. And it'll be a thing that's going to connect to another service. And when the data comes back, I'm going to be given a reference to an RSocket. That's the RSocket that I can use to make calls to the service to which I've connected, right? So on localhost 8888, I'm now connected. Here's my reference to a working live client, which I can do. I can say I want to get a request response, and I'm just going to send a string in, default payload dot create. And, let's just say Spring fans, right? Good. And when the data comes back, I'm going to unpack it. I'll say, let's map each payload that comes back into a string. And I want to log that. So this is actually flat map many. And I'm just going to subscribe to the whole thing and log it out. So system out print line. Okay, good stuff. There's the read-write interaction. Replace it with a lambda expression. I don't need to. What am I expecting back? I'm expecting to make a call to the service and get a string back, and then I want to write it out to the console, right? So if that works, it should work. Let's go ahead and start it now. Oops, I forgot to do the other thing. I forgot to do the same thing here, didn't I? So, system.in.read sneaky throws. Restart. There you go. There's a single value. Now that's a lot of code just to get a single value across the wire. And as we just talked about, there isn't even support for things like routing. So now let's use Spring to do this work. Okay, so let's get rid of literally all of that. Just get rid of it all. We don't need it. Don't need that, and don't need this, and so on. So now we're going to do the same thing with the Spring component model, because we've actually integrated this Reactor-based Java client into Spring Framework itself. So what I'm going to do is I'm going to create a controller. Right, I'm going to actually just go down here, class greetings controller. Okay, and I'm going to return a reactive stream of values, or actually let's just do a stream, a single value, just like we did before. So it's like for like. Okay, so greeting request. Okay, class greeting response. It's a little bit more involved actually, because actually I'm encoding an object as opposed to just a primitive string. So you can see that it works. Private string name, data at allargs constructor at noargs constructor. And I'm going to take that over here. Response message. All right. So there's that, and this is a regular Spring controller, so add controller. And in order to satisfy the endpoint requirement, I'll create an endpoint. I'm going to give it a route so people can find it, right? That's already handled for you by the framework. Mono of greeting response, greetings request, return. And actually, you could probably just get away with just that, right? Since it's a single value anyway. So return new greetings response, hello greetings request dot get name at, okay, or exclamation mark. So there you go. That's the entire service. In order for this to work, I need to do some configuration. I need to run this on RSocket server port 8888, same as before, right? Otherwise, so there's that. And now on the consumer side, well, let's restart this. Let's make sure that's all working. On the consumer side, I'm going to copy and paste these DTOs here, and I'll use them to make the same call using an RSocket requester. So an RSocket requester is the client, if you will, for RSocket services. But again, it's once you're connected, you're not actually a client or a service. So it's a bit of a misnomer. So we avoided that by using the right names, right? Okay, builder, return builder dot connect TCP localhost 8888 dot block. Okay, there's the requester responder, and I can use that now to create a bean that's an at listener, an event listener, so an application listener, application ready event. Okay, return events. Alrighty. Now, here I'm going to use my RSocket requester, rr dot route greetings. Data that I'm going to send in is the greetings request, so Spring fans. And then the response I'm going to get is our greetings response. And I'm going to map each one into the constituent string message. And I want to then subscribe to that. Actually, I'm not getting a stream, am I? I'm getting a single value, so it's a mono. A flux is for multiple values. And then for each one, I'll just log out the result. All right, let's see if that gets us there. Oh, access denied. So I have Spring Security on the class path here. I need to comment that out for the moment, just for the interim, just for a second. Command-Shift-R, re-import. Okay, and then restart the consumer. Groovy, there it is, huh? So we've got data. We were able to send a request to the first node and get a response back in much more succinct fashion, right? So all we're doing is we're creating an RSocket requester, and then we say RSocket request routes. We give it the route, the payload in, the kind of data that we expect back, and then we can just process it, map it, do whatever we want with it, right? Okay, so that's a very simple RSocket interaction. I do want to secure it, right? And so we have full support for Spring Security here. I'm going to go back to my build here on the service side, and I'll re-import these dependencies, which I just a few minutes ago finished commenting out. Re-import. I'm going to rewrite this code a little bit to take advantage of the fact that I've got an authenticated user. Now, what I want to happen is I want to have an authenticated user that comes in and makes a request, and that I can use to then, respond accordingly. I want to use the name of the authenticated user rather than this payload. So what I'm going to do is I'm going to create a new endpoint, greeting response, greet, and it'll be authenticated principal. mono of user details. Okay, user detail mono, and I'm going to say user detail mono dot map ud dot get name. Map this name to a new greeting request, and then flat map that gr into a call to this dot greet gr. Okay, so what I'm going to do there is, since I'm returning a reactive stream, I might as well just change this to be a mono. Makes it easier now. And this can be just a flat map to a mono of R. Okay, and this would be a mono as well. Mono.just. Okay, good. So there's the reactive code taking the incoming authenticator principal. Okay, very good. There's the entire thing. Okay, now that's much easier to, that's what I want. I don't want to have to send the username, the user into it. I just want to have an authenticated request. In this case, the data that's going in is no longer the greetings request. It'll just be, mono.empty, for example. Right? That'll be fine. That said, I do need to install Spring Security. Now, Spring Security does two things. It does authentication and authorization. We're going to look at authentication here very quickly. I'm going to use a hard-coded in-memory database. Don't ever do this. This is a terrible idea, right? You want to use a something like an IDP, like a OAuth or SAML or LDAP or whatever, right? Anything better than this, but for our demo, it'll be fine. Okay, so roles user dot build. There we go. So there's my simple hard-coded list of usernames and passwords. Now consider that when Spring Security does cryptography is one of those things that has to block. It sits there on a main thread and monopolizes the CPU, so it blocks. And so naturally, you need to make sure that you understand that behind the scenes, this is actually going to do that cryptography on a separate thread pool. But you're still very much encouraged to not do anything that requires excessive cryptography. So do OAuth. OAuth requires you to do cryptography when you exchange your short-term credential, your long-term credential, like your username and password, for a short-term credential, like your token. That's a good win. That's a nice situation, because there you get better security and better performance and better scalability. It's a win-win-win, and I love when we can get that. Okay, so I've got authentication. Now I need to actually lock down the service. I want to lock it down. So payload socket acceptor interceptor. So this is authorization for our socket, right? Our socket security. Security. Okay, return security dot build dot authorize payload AP dot in exchange is going to be authenticated, and I want to support simple. I can do JWT, but I want to do simple because I'm just doing simple here. But you can do JWT based tokens as well, right? Okay, so that's this. That's going to lock everything down. The only thing that's missing is Spring and the RSocket integration doesn't understand what this annotation means by default. You have to configure that. So RSocket message handler, okay, and I'll say var mh RSocket message handler mh.get argument resolver dot add new authentication principal name resolver mh dot set RSocket strategies. I'm going to inject that here, RSocket strategies. Okay, and return mh. Good. So there's my RSocket message handler, my authentication, my authorization, etc. That should give me everything I need to lock this application down. Now on the consumer side, I need to authenticate when I make the call, right? So I need to actually convey some metadata. So I'm going to create a username, password. Oh, I need my, yeah, I've got that there. So username, password, metadata, credentials, new username, and the username will be JLong password PW. Obviously, don't store this in plain text if you're all going to do usernames and passwords. MIME type is well-known MIME type with a 2 L's, not 3. Okay. Authentication dot get string. All right, so I'm creating a MIME type there, and I'm going to use that to make a connection, right? So the only thing is that RSocket by default doesn't know about this kind of authentication, so I need to actually do a RSocket strategies customizer. Okay, customizer strategies dot encoder, new simple authentication encoder, right? It's again one of those cases where it's very flexible to the point where you have to configure some of the basic stuff all the time. Okay, now when I connect, I can either do authentication, as I just said before, on the connection in the setup payload, right? Setup metadata. So this dot credentials, this dot MIME type, or I can do it per transaction, per request. So I can say and then metadata, and voila. Okay, same thing basically. Either way, let's go ahead and run it and see what we get. All right, there we go. Hello, Jaylong. Well, with that, my friends, thank you so much for watching. I hope you got a good feel for what RSocket is and why you can use it in your application. It's a really full-featured thing. We've got it integrated in a lot of different places. I didn't get to show Spring integration here. I didn't get to show the Spring Cloud RSocket broker that we're hopefully working on, where we are working on it, but it's actually work that's being done in conjunction with the RSocket project in the Reactive Foundation, of which the Spring team and Alibaba and Netlify are founding members. So there's a lot of good stuff coming and a lot of stuff already here. Everything I showed you today is GA. There's nothing that it requires a pre-release build or anything. This is stuff that you can use and has been out there for months and months and months, if not years in some cases. Thank you so much for your time.
Thank you for this really fast-paced talk. I think I will have to rewatch it in a slower version because that was really fast for me, at least now after a whole day of conference. Really hard to grasp for me. Yeah, we already have some questions in the channel. I will just forward them to you, and let's see how many questions we will receive. So,
Sure,
Pierre, I hope I pronounced your name correctly. How does AirSocket compare to Stomp, which is used by the Spring Boot WebSocket starter?
So RSocket is a whole protocol, right? Stomp is a bit of a kludge. It's a bit of a hack because what we use Stomp for is to encode a envelope which has a payload and headers. And so WebSockets don't have headers by default. Maybe that's some background that's important. WebSockets don't have headers. It's a protocol that was built just to send things asynchronously to a client, but there's no header. So the question then is, how do I propagate out-of-band information like tokens that I need for security, right? And so in order to get around this limitation, the community created yet another layer called Stomp. So when you do WebSockets with somebody else, you need to agree on payload, Stomp, and then WebSockets. There's 3 different layers of things to agree on. So you can run that. You can run. You can use WebSockets like that if you want, or you can encode RSocket on top of WebSockets, right? But you can also do RSocket on top of TCP or on top of Aeron. And so I don't know if that really speaks to the. There's just they're 2 different things, right? One is for the web, one is for the browser, and one is a general purpose remoting mechanism, or one is a general purpose communication mechanism that gives you the ability to transport over a number of different protocols, including Aeron, including WebSockets, including TCP. RSocket has headers. It's designed to be completely bidirectional. It has stateful connections. It's fully featured, etc. And the payload is agnostic, so it's very different from Stomp in that, some of the things that Stomp provides are built into RSocket.
Okay, thank you. I hope, Pierre, that sufficient answer for you? If not, please follow up with another question. I'm really sorry. I'm a little bit already baffled by the whole day, and it's a little bit exhausting for me already. So I'm not that good in questions. I would more ask question like going into a different directions. And so shortly, I had no time to introduce you because you were a little bit late at the beginning. So would you love to introduce yourself again a little bit to the audience so that they know who you are? You did that at the beginning of your talk, but it's still quite interesting to hear it from you again, actually.
Okay, well, my name is Josh Long. I'm a developer. I'm a Spring developer advocate on the Spring team, and I have been since 2010. I'm an author of several books. I do a screencast, a podcast called the Beautiful Podcast. And I love the JVM. I'm a Java champion, a Google GDE for Kotlin, and just very happy to be here.
Okay. I did not know that you're a GDE for Kotlin. Compared to how to say that best, what do you like most about Kotlin, or what would you miss in Java? What Kotlin provides actually?
Coroutines. So
Okay.
everything I just showed you in this video, showing reactive APIs, automatically gets mapped into coroutines if you're using Kotlin. So you can have your cake and eat it too. You can write coroutine code which looks deterministic, it looks imperative, and yet behind the scenes it's actually using these reactor-based APIs to do asynchronous, non-blocking, computation. The result is that you get the better result with less lines of code.
Okay, cool. Yeah. Cool. I'm sorry.
No problem. It's super
but
early for me and it's late for you, so
yeah,
I get it.
So
Well,
we are in the Java stream, so I will just reference to Java basic questions. And what is your favorite JVM feature actually? So what do you love the most in the upcoming preview, also in the current preview, or what is the feature you mostly dared to be in the Java ecosystem? What is the feature which influenced you the most actually?
well, right now I'm very excited by Project Loom, Project Panama. Project Loom, of course, gives you lightweight green threads, so it's a much more scalable thread pool, basically. That's it. That's one opportunity. Project Panama gives you integration with native APIs, so it's a better foreign function interface for Java. It's sort of like JNA or JNI before that. It just goes a step further, so you can very easily link to native code from your Java code. I feel like the JVM, we've managed to do an okay job over the last 25 years of never needing to call into native code. And if we do, it's a nightmare. Anybody who's ever written C++ and C++ and C are not that difficult. C++ or C or Objective-C when linking against JNI is an absolute nightmare. So highly recommended that you avoid it. This is much better, right? This is a nice, simple interface, and it gives us what every other language out there for the last 80 years has, right? Which is easy integration with lower level abstractions, lower level APIs. So that'll be nice. And then the other thing I love is records, right? From a syntax perspective, records feel like a long overdue feature. Multi-line strings are nice. Smarter switch statements, that's nice as well. Smarter auto casting, basically, for in the context of an if expression. All of this is stuff that you get in Kotlin, for the last 10 years or whatever. But I'm very happy to see it in Java. It shows that the team that works on Java are really, really working hard to make it the best option for the most amount of people. For the largest number of people, they're doing a great job.
So, based on what I hear, am I right when I assume that Kotlin is your favorite second JVM, also your favorite second JVM language besides Java, or do you prefer something else like Scala or things like, or I don't know, Clojure or what's out what is out there?
Yeah, for me, for my own purposes, I quite like Kotlin, but again, I've done talks in Groovy, I've done talks in Scala, and I've done talks in Java and Kotlin. For my own code, I tend to write a lot of Kotlin or Java, but I have no religion about it. I just want you to use Spring as opposed to what language you use. I don't care. It's all of them work great in that respect.
Okay. Some chat. If you still have questions, feel free to ask. I have another question. How just now a little bit non-techy. How
Yeah.
is how you as a? I mean, I've seen you are already on a lot of conferences, and I think a lot of your job is really flying around and going to conference. How is it now? Are you heavily ground based currently due to COVID-19, or is it
Yeah.
still a lot of going on with online conferences? Did that influence your lifestyle in a better way? So you have now more home time, or how do you see this whole situation?
Yeah. So I mean, I used to travel a fair bit. I did 650,000 miles last year. You know, just going from one show to another, one country to another, 6 continents, dozens and dozens of countries, and even more cities, all last year, right? I do that every year, and I tend to keep busy. And this year, you know, because of the crisis, because of the pandemic, because of the, let's say, mismanagement of that crisis by certain governments worldwide, right? We're seem to be in this prolonged situation where a lot of us are just staying home, and I'm okay with that. Yeah. As for my ability to continue to extend my reach, well, it's been a pleasure because of great conferences like this one, and because of so many others that have sprung up in their intervening months. You know, I've kept my dance card very busy. Every week I do a few different shows and a few different conferences, and of course I still talk to customers as well. So all of that I do, and to be honest with you, most of my engagements, most of the interactions are, as I alluded to earlier, overseas, right? So when I talk to somebody, you know, it's usually that's why I'm really tired right now, is because most of the times when I interact with people, I interact with them at, you know, 5, 6, 7, 8 o'clock at night, in the evening, California time for Asia, or midnight for Europe, right? Much later in the evening. So my sleep schedule is a little weird as a result, but it's been fine. I've really enjoyed being home with my partner and our kids. So that's nice.
Cool.
Just kind of a bummer we have no place we can go, you know?
I can understand it. I was locked up with 2 kids also the whole time at home. It's quite challenging over the time, let's say it that way. But also a nice experience. So I don't think we were that close for a long time, actually.
Yeah. I have asthma, so I'll be stuck indoors for as long as it takes to get a vaccine or something, I guess.
Yeah, cool. There are no questions in the chat anymore. Do you have something you want to tell us about? Because else I would close this session then, and I would head out to the closing keynote. I think it's by Kevlin Henney.
Good.
Kevlin Henney, which I also want to invite you. I want to say thank you for your time. It was a pleasure talking to you, and I will definitely take the time to manage to take a look at the talk in a slower or in a state where I really can dig that into. I haven't seen anybody configuring Spring that fast, I have to say, besides you on live talks. But I think you are still a little bit slower on live talks because you look up into the crowd from time to time.
Livebox? What's that?
No, at live talks.
So when live talks.
You from time to time look up into the crowd, so you stop coding a little bit. Do a little bit.
Yeah, there's a little bit of a breath. And also, most of the talks that I do are an hour long. This is the only one I've ever seen that's half an hour. So I had to get more done in less time. I don't know why it's a half an hour. Maybe we could change it next time to be at least 45 minutes.
And we need to talk with Nicola about that. Yeah, well, thank you. It was a pleasure having you, and good morning again, and have a nice day.
And to you as well. Stay safe, everybody. And cheers. Thank you very much for your time.
Bye.
Bye.